Good morning, everyone. My name is Jafar Sadiq Ali, working as a professor in Electrical Electronics Engineering Department of Sri Muthukum Institute of Technology, Chennai. I'm handling the subject IoT concept and applications. Now we move on to the syllabus, Unit 1. Already we have covered all the first line, the topics evolution, enabling technologies, and architectures. And the now we are going to see about the simplified IoT architecture and the stack format, that is Forge Edge Cloud Paradigms. Fog Edge Cloud Paradigms. In this part of this IoT architecture, we have seen the two main types, M2M and IoT World Forum architecture. And there are some alternative IoT models also available, so which we see in this class. So one is Purdy model for control hierarchy. This is the one alternative model. The second one is Industrial Internet Reference Architecture (IIRA) model, formed by the Industrial Internet Consortium. So this Purdy model for control hierarchy is commonly and widely well understood model that segments devices and equipments into hierarchy levels for functioning effectively. So this what first we are going to see. Later on we are going to see the IIRA model, which is mainly used for industry oriented applications. Mainly critical industry oriented applications only we are going to use this IIRA model. The first we go through this Purdy model for control hierarchy. It has got level 0, level 1, and level 2, and a level 3. The last one is level 4. Level 0 is the basic level wherein we have the sensors and actuators. Both are kept in this physical process layers or data link layers. And level 2 is the next hierarchy wherein we have the some PLCs, programmable logic control unit, and or DCS controllers. It contains many PLCs and SAS. So through programming, we are able to have some basic controls over the below physical data link layer devices. And this is the level 1 and level 2 play a major role of actual physical world devices and controlling physical world devices. Either can be in the local plant or in the remote site also. The third level of control is supervisory control. That's the level 2 control. It's called as a level 2 control. It's nothing but the SCADA. It uses the SCADA as well as HMI, human machine interface. That's a feature we has, and also SCADA also. Supervisory control, all you know that. So using SCADA as well as HMI, we are able to have the supervisory control over the level 1 basic control and the level 0 the basic physical devices control also we have. And next hierarchy is operations systems control. That's called level 3 control, and in this only applicable only for the local plant only. Historical data has been stored, archived, and we can make use of those systems, for our operations. And the last and final control is level 4 control, is called as a enterprise control. So enterprise control in the sense it includes everything, all the levels comes under this enterprise control only. It has got security systems enhanced in this, because all the operations has to be closely monitored and should be safeguarded from the any other cyber securities or any other threat also. So that plays a major role as part of this IT security. So this hierarchy level model is being introduced by the Prude model. This is the one such IoT model, alternate model. And that's what is explained here. Level 0 physical process, actual devices for actuators, motors, relays, valves, generators, or LEDs, bulb glow. So that comes on a physical process. Second one is basic control process. It's using the PLCs or PID controllers. If you want to fine tune some systems, means they can use some basic controls. Use then level 2 is area supervisory control. Supervised control means SCADA as well as HMI. You can make use of it for monitoring as well as controlling actions. And the next thing is level 3 is site manufacturing operations is operation control, maintenance, quality maintenance, preventive maintenance, predictive maintenance, production scheduling, and all this comes under this level 3 control. And the final last one is, as we seen, enterprise control, ERP control, enterprise business systems. Using some SAP or Oracle, we can able to manage the planning right from the logistics, finance, supply chain management. All this can be controlled at one place. So this is the Prude model for one, one type of IoT model. The second thing is IIRA control. For industries, it's broadly usable. See here, its implementation viewpoint is as a data layer is something with the implementation viewpoint. And there is another way you can use sector. You can see this industry sectors, right from the healthcare sector, energy sector, transportation sector, and manufacturing sector. You can have n number of sectors, or in all sectors it's broadly applicable, and the life cycle process is clearly defined right from the conceptualization. What is conceptualization means? Idea formation, what the problem, or what is the root cause of the problem, or what is the change request need to be done in the system, or that's what the called as a conceptualization area. Then from the idea, next one is requirement. What are the requirements to do the particular idea, to achieve that particular idea, or to realize the idea into reality? What are the main requirements we need to analyze? And everything after we have gathered, we need we are able to in a position to make the prototyping of such a idea into a small systems. It's called a prototyping, or you can call it as a design area. Design using the some software also available. You can build by in the pictorial format using the design. It's called design phase. And once the design has been modeled or prototype has been done, then we need to do the actual development in reality. In reality, how we are going to make that particular idea into a reality. Development phase. It's called as a build phase. And once the build or the development phase is get over, the next one is testing phase. Testing means to test the to check the validity of the particular uh, developed item is passing or failing some of the test conditions. Uh, that's called a validation process or verification process. So all this comes under test phase, and once everything it passes through, no, there's no failures. Then we can go for the deployment. So from idea conceptualization in to deployment of particular uh, idea is the life cycle process that takes place in any industries. And the viewpoint also has been clearly mentioned as business people, business owners, what they have the strategic viewpoint. From their angle also, we need to be able to provide the such facility. And usage point of view, mean the end users what they will find comfortable in that angle also, we need to be able to visualize it. And functional viewpoint, this is the actual functionality of particular product has been should be clearly defined in the user guide or whatever the user manuals. The implementation viewpoint, if you implement what are the labor mandates or what are the raw materials and what are the health hazards, safety hazards, and what are the things required to attend the any if any emergency happens. Everything has to be viewed in that particular area of viewpoint. So all this gives you the broad applicability of one deployment of any IoT product. So this was the summary of the IRA standards. I'll go through this. And the last and final one is this stack format. We have cloud computing and fog computing and edge computing. On the syllabus is given as the last one. The one is cloud computing, fog computing, edge computing. Cloud computing is nothing but the centralized computing model in which data generated by devices is transmitted to remote cloud servers. For what purpose? Storage of data and the processing of the data and analysis of the particular data to get a useful information to the business owners or the end users. So cloud means classic examples Google Drive or Google Mail is a cloud computing one such example. Characteristics is centralized architecture. It's a one architecture only, centralized one. Everybody can access this. So highly computational and the storage capacity is available in that. It's a very costly one. You can't easily afford it. You have to pay premium price and you can make use of it. It's a very highly because they have invested a lot of money into that. So high computational and storage capacity, suitable for big data analytics and AI modeling training. It's not for small business purposes. Very big giants can go for this cloud computing purchase only, and it requires 24 hours high speed internet connectivity and it's higher latency compared to fog and edge. What is mean by higher latency means the response time starting from your request time and what you get the result response time, it's going to be a very higher one in case of cloud computing because it has to travel with all the data packets from one place to the remote servers and get back to the original place. That's the main thing is higher latency compared to see fog and edge computing. We will see the later on what is fog and what is edge computing. Its advantages is virtually unlimited storage. Yes, you can go for unlimited usage of it. It's very powerful processing capabilities. Yes, it's a high speed, high supercomputers are available. You can make use of that capabilities. Easy scalability and centralized management of resources. Only one copy is there. Everybody can use it. A limitation is higher communication delay. This is what latency, higher latency, where it takes some amount of time. And increased bandwidth consumptions. Bandwidth also has to have a very large bandwidth. That's why I said small companies cannot afford it. Big companies only can afford this type of cloud computing. And dependence on network connectivity. Yes, network should be always available. And next we move to fog computing. Fog computing is thing, but it's a distributed computing model. Whereas cloud is a centralized computing model, and the fog is a distributed computing model that processes and stores data at intermediate network devices such as gateways, routers, and local servers, which are located between the edge and the cloud. See the structure of this cloud is the topmost one, fog is the middle one, and edge is the bottom one. So this is the in between it happen. It lies. That's what gateways are routers only. We have some computational softwares and the memory spaces and some CPUs are available, which will help you to solve some of the processing data, storing of data for a intermediate devices only. So main advantage is faster response because compared to cloud computing, it's much faster and reduce network traffic because it not go to the cloud. In the fog itself, we can get things done and improve reliability and scalability. Better support for IoT as well as real-time applications. Now, what are the limitations of this fog? It's less computation power. Yes, obviously, cloud has more and more super fast computing CPUs are available, wherein we have less computational power than the cloud servers and more complex management due to the distributed nodes. Here the nodes are distributed. That's the only drawback. Then we need to manage the thing that's going to be a huge complex one. That's what the main limitation is. So this is what the fog is. Now we move on to the edge computing. What is edge means? Edge computing means it's a distributed computing model. Again, same as that of the fog only, but in which data processing and analysis are performed directly at or near the data source itself, such as sensors, actuators, cameras, or IoT devices. Yes, as I told earlier, this device itself, there is a provision for data storage as well as the processing of the data, and we can need not go to the gateway itself. Without gateway and sending out the data packets from one place to another place, within the device itself, we do all the processing and analysis directly. And this called as that's why CAT is first point is called as a decentralized architecture. So one sensor will have this data only. I cannot check the data from the other anywhere in the world. Whereas cloud and fog, I can able to check. But edge computing, what is happening, I can just only if at all I get the permission authentication to go into the particular server sensor device only, I can able to check the data. Otherwise, I cannot. That's what decentralized architecture. And the main thing is it has a very low latency. Means there's no transportation happened. Same place, same data, processing, what result is published, finish. So minimal net bandwidth is required, and advantage is faster response time. Fastest, and reduce network traffic, control dependency, and see the limitations. Limited storage only because this device is very small device, so you have also will have a very small capability auto for storing as well as processing capacity, and also higher maintenance effort for distributed devices. Yes, each and every device has the life of the battery. Everything has to be thoroughly checked on a periodic basis. That's why it requires higher maintenance effort. So the last one we have come to this conclusion of this first unit with the comparison of cloud computing, fog computing, and edge computing. And see the parameters. The last one is the distance from the users. Cloud is very very far, Fog computing is very near, and edge computing is the very very closest to the your devices. And as we have discussed, this point is very very useful for you. Make a note of it, and it gives you everything in a nutshell. See, as I said, example of cloud computing is Gmail, AWS services, fog computing, nothing but the smart traffic and management systems, and edge computing, nothing but the wearable devices, smart cameras, everything comes under edge computing itself. So with this, we conclude our sessions. Thank you.